Hello everyone, welcome to Season 1, Episode 7 of Maintenance Motorway. If you watched Season 1, Episode 6, you remember that we talked about how to properly jump a dead vehicle. In this episode, Season 1, Episode 7, we're going to be talking about how to pick the right jumper cables. Now this video is going to be a bit more technical, but we're going to really try to simplify it because our goal is to, provide as much information as possible to vehicle owners in a very simplified way so that, they have as much information as possible to make the best decisions for their vehicles, okay? That ties into vehicle longevity, ties into safety on the road and things like that. So sit tight, guys. It's going to be technical, but it's still going to be fun. So let's get to it. All right, so jumper cables come in different sizes, and the most important thing you want to focus on when it comes to jumper cables is the thickness of the cable. We're going to get into that here shortly, but if you look at this is a 6GA, so basically this is a 6 gauge jumper cable. And if you watched our video in Season 1, Episode 6, we talked about the importance of the thickness, and we recommended going with a 6 gauge. In this video, we're going to be talking about the different gauge sizes and then how they actually affect the jumper cable's ability to start a dead vehicle. Okay guys, so this is an engine that we have here in the shop, and I'm going to use this engine to demonstrate what we're talking about here. So we just want to start from scratch, okay? Now the purpose of jumping a vehicle is to get your starter to turn the engine, okay? Now this actually sits in here, but we're taking it out. It sits at the back of the engine here. This is called a flex plate, and automatic transmissions have a flex plate and manual transmissions have a flywheel. I'm sure most of you have heard of flywheel before. So how this works is that I don't have a starter with me, but basically the starter sits on the engine as well, and it has gears that connect into these holes here. This is called the starter ring gear, and the starter itself has a pinion gear, okay? So the pinion gear contacts this ring gear, and then when you start your car, the starter contacts this and then turns this pinion gear, and that turns the whole flywheel and turns the engine and gets the car started. Okay, so that's how this process works. The starter needs a lot of current to start the engine, and what we're going to see is that the current that's available to the engine is related to how thick your jumper cables are. Okay, so that's what we're going to talk about today, and we're going to prove that today. That's why it's so important that you have the correct jumper cables in your vehicle to start your engine, just in case you have an emergency by the roadside. Okay, so let's get to it. All right, so as we were saying, we're just talking about this. The starter pinion gear needs to engage the starter ring gear, which is on the flywheel or the flex plate of the engine, and start the engine. So that's how the engine gets started. Now to do this, the starter needs high current. Okay, so we need a lot of current. Now some of you guys may be interested in this, but the process through which this current is generated is called electromagnetism. And basically the starter contains a magnet. So when you run electricity through it, it interacts with the magnet, and that is the process of electromagnetism, and that is what really generates this current here, okay? So that's just by the way, if you want any more technical detail there. Now right here we have V is equal to I times R, where the I is the current and R is the resistance. We're going to get into that here shortly, but this V here is basically the battery voltage. Most cars have 12 volts for the battery, so we have 12 volts, which is available for the generation of the current. Now the current and resistance you can think of this way. When you have water flowing through a hose and you block the hose a little bit, you are basically providing resistance, okay? Once you take your finger off the hose, you have more water flowing again, and that's basically the current. So okay, so the flowing water is the current, and then when you put your finger over the hose, that is a resistance. Okay, I hope that makes sense. So for our purposes, we want the resistance to be as low as possible and the current to be as high as is needed by the starter. Okay, so for instance, if we know we already have a battery voltage of 12 volts, so if we have a resistance of say 6, it means we're going to get 2 for the current. If we have a resistance of say 4, then we're going to get 3 for the current. Okay, so this is where this is going. I hope this makes sense. We want as much current as much as possible so that we can get enough current for the starter. Starters require current between 150 and 300 amps, so that's a lot of current. So we want this resistance to be small. The resistance itself is a factor of a couple of things. One of them is the what we call the resistivity, and the other thing is the length, and also the other thing is where we really want to focus on today, the cross section of the wire, in this case this is the thickness of the jumper cable that we are looking at. Okay, now this resistivity it depends on the material, and usually the jumper cables are made of some kind of copper, so the resistivity is usually the same throughout the different materials. So we're going to simplify that and say we'll go with a resistivity of 5, okay, just to simplify that. And one thing I forgot to mention here is that if you look at this formula again, the length is also a factor. The length of the jumper cable is a factor. Let's just standardize this and say a length of 12, which is pretty standard if you're going to buy jumper cables. Usually 12 feet is the standard length you find on the market. So that means that this resistivity times this length together will give us the 12 times the 5, which is 60, okay, just to simplify this. And now we're going to get into how the jumper cable thickness actually affects everything. Now, if you can see from here, all these factors, resistivity, length, and the A, which is the cross-sectional area or the thickness of the wire, are the things that dictate the resistance. So we want this resistance to be small, okay? Don't forget that. So that means that if you look at this formula, as the cross-sectional area gets bigger, the resistance gets smaller and vice versa, all right? And now again, in the interest of simplifying, we have different wire gauges here. We just looked at wire gauges at the beginning of this episode. So the thing about wire gauges is that the smaller the number, the thicker the wire. That's quite interesting. It's not intuitive, but that's how it is. So if you look at this 4-gauge wire, it's thick. It's thicker than the 6-gauge wire, and the 6-gauge wire in turn is thicker than the 10-gauge wire. It's just how it works. So if there was a 20-gauge wire, it will be smaller than all these, okay? There is a 20-gauge wire, but those aren't used for jumper cables because they're just too small. So this is what we have. Now, here we further assume that this 4-gauge wire has a cross-sectional area of 30. This 6-gauge wire has a cross-sectional area of 20. And this 10-gauge wire has a cross-sectional area of 10, okay? Just to simplify the calculations. So, since we know all the cross-sectional areas, and we know the resistivity, the P, to be 5, and the length to be 12, we know that we want the resistance to be as low as possible, okay, so that we can get the highest current. Now, if you look at this thick wire, the thickest wire, we divide the resistivity and the length by the cross-sectional area. This gives us 2. So that's 5 times 12, which is 60, divided by the 30, which is 2. And then we do a similar thing here to get the resistance for this 6-gauge wire. That comes to 3. And then a similar thing for the 10-gauge wire comes to 6. So now, how does this all play into our final current, which is needed for starting the starter, okay? Now, based on, we know that our voltage is the I times the R, so it means to get our I, which is the voltage, which is the current needed for the starter, that's going to be V over the R, okay? So we have here for the current for the thickest wire, we have 12 over this 2, which is 6 amps, okay? And then for the 6-gauge wire, we have 12 divided by this resistance, which is 3. That gives us 4 amps. And then for the thinnest wire, we have 12 divided by 6, which gives us 2 amps. So you can see that the thicker the wire, the more current we have to, jumpstart our vehicle. So that's extremely important. So this is really the gist of it. Now the question is, based on your kind of vehicle, what kind of jumper cable thickness do you have to buy? What kind of gauge jumper cable do you have to buy? So if your vehicle is like a V6 and below, we recommend you get the 6-gauge wire. If you have anything more than a V6, like a V8 and V12 and stuff like that, you want to get a 4-gauge, because that's definitely going to have more current to start your vehicle. Now, mind you, these are just numbers that we use to explain the whole concept, but I mean, starters require a lot more than this. Like I was saying, 300 amps is not unusual to see on a on a startup for a sizable engine. Okay, so these are just numbers to kind of make it round figures to make it easy for you to understand. But you definitely want to, have at least a 6 gauge if you have anything V6 and below, and a 4 gauge if you have more than a V6 engine. I mean, if you want to go 10 gauge, you can. There's also 8 gauge if you want, which will fall in between this and that. So if you have like a Matiz or a Picanto or an Atos, you can go with either a 10 gauge or an 8 gauge, which falls in between here, like we're talking about. But we really recommend nothing thinner than a 6 gauge for just to make sure that you have enough thickness on your jumper cables to start your vehicle. Well, folks, this brings us to the end of season 1, episode 7 of Maintenance Motorway. We know this episode was a bit technical, but we hope you guys enjoyed it and learned something from it. As usual, thank you for your time, and don't drink and drive, don't text and drive, and always practice defensive driving. Take care.